Thank you, Ed.
Yep.
So Tom ended up making that fairly good of all your past videos.
Yep. Yeah, I saw a little bit of it. Tom sent me. Yep.
Nice.
I need to get a webcam or something.
I sent you the link.
Yeah.
Yeah, he's talking about being okay.
Yeah. I mean, I can. I'm using my MacBook, so I can use my webcam for my MacBook. But yeah, I want to use my PC. Tom sent me.
I'm doing the feedback group.
Yep. Nice.
Yeah, it was me. I got it. Hey, Garen.
Hey, how's it going, Tom?
How's it going? Hey, Garen. Good. Hey, I want to introduce Matt. You both went to UPenn, so I guess you guys have like a lot in common.
Nice to meet you, man.
Thank you for joining us.
Yeah,
You had a question?
thanks for setting this up. No, I was just saying, what year did you graduate Penn?
2016.
Oh, okay, nice. I was in 2013, so it's not too much overlap.
Okay, nice.
Oh, I didn't know you went to 2013. Hey, Evan.
Hey, what's up?
How's it going?
Yeah, pretty good. How's it going with you?
Not too bad, man. Just enjoying the summer.
Yeah, man, I was just at Central Park. It was mad nice.
Cool, that's awesome.
Yeah, this week has been incredible weather on the East Coast.
Seriously, yeah, it's just like, I'm amazed. I don't know.
Yeah. Harder program when the weather's that good.
Yeah, it's hard to even just work, honestly. I'm like looking out my window or like the sun's creeping in and I'm just like, oh God, like what am I doing?
Yeah, bring your laptop outside. And then the
Can't
glare.
see the screen. Yeah,
Yeah. Oh God.
so bad.
Hey, Garen, how's the weather in London?
It's actually been arguably the best spring that we've ever had in London, and of course we've been in lockdown the entire time. And then the moment that we start relaxing it, it's rain for the next 10 days.
Oh,
Of course.
Oh wow.
So it is. It's a bit of a tease, I'm not gonna lie, but we had a stretch of probably a month and a half where it didn't rain for like a day. It was gorgeous.
oh, that's nice.
That's surprising for London.
Yeah, it was shocking.
All right, I guess I'll kind of kick it off. Edwin or Evan, do you want to say something?
Oh no, I was just making more small talk.
Yeah, okay. I'll kick it off with some updates. We got some feedback for requests on topics. We'll kind of go through them at the end of the day, kind of grab some and figure out what we want to go do like the upcoming weeks, and then what we can kind of get people to sign up for, because some of these things are a little bit more in depth and they're not so much group discussions as tutorials on technologies. And I think so that would actually be good to kind of get people figuring out what we want to do and whatnot. So we'll touch on that a little bit later. The other thing is we've talked about like pursuing contracts as a coding guild or as a tech camp. It's kind of like the two organizations that are working on it part-time. Coding guild being like the community aspect of these things, and the tech camp being the actual content creation aspect of things. And so one of the early ones we kind of got wind of was a online legal course was pursuing kind of work for it, so we're still in the talks of that, to see how that kind of come along. But most recently, we got put in touch with a teacher at a New York City public school looking for a data science curriculum. So we're going to be trying to get that and see if that can kind of work out. Ideally, we kind of create the course content separate from this, but like one of the big things that I think is super important in learning is kind of creating a community aspect of it. So if we get the New York City public school ones, I think merging both the like course content is going to be super powerful, but also like making sure that there is a community around that, and then kind of also inviting them into this community. So making sure that we, like as a group, we're mentoring younger people and making sure they're kind of upskilling all the like next generation of coders. So those two opportunities are, super great opportunities. Naturally, we're not going to count on them. We're not going to, nothing's guaranteed in this world, but there are cool things on our horizon. So there are things that we're going to be pursuing, talking about as things go. If either of those things kind of seemed more interesting, definitely reach out, especially if you want to help any of the work or any of the curriculum making. We're definitely kind of going to be looking forward to definitely going to need some help, and obviously there's going to be some sort of compensation involved with that. Yeah, so those are kind of the two big announcements. This week, we're going to be discussing kind of the coding journey, which I think is a very interesting topic, just in general to talk about, but it's also part of what's going to kind of influence a lot of my work for curriculum development, right? And so part of the generating good discussion topics is that we all should benefit from it, but I also kind of suggested this topic selfishly because I think I could particularly benefit from hearing your guys' coding journeys and hearing how you guys kind of, what you guys think are good milestones and what you guys think are important steps along that path. So I'll kind of pause for a minute, see if anyone has questions on that front, and kind of proceed from there. Doesn't seem like anyone has questions. Edwin, are you on the line? Do you want to take over for lead coding?
Sure. All right, time for the weekly leak code. All right, so I'm going live now. All right, let me know if you can't see the screen. But yes, so this is a greedy algorithmic problem. So we haven't covered much about greedy algorithms, and essentially greedy algorithms are an approach of solving a problem by finding the locally optimal point in time, and by trying to find a local optimal solution, you'll eventually be able to approach a global solution to this problem. So it's not as difficult as it sounds like, and I think it's a useful approach to practice. So this is a problem that we'll be practicing a greedy algorithmic approach to. So this problem is container with most water. So given a list, given an input of, say, a list of integers, each integer value represents the height. So just think of this as a histogram. And our goal is to find the biggest area, or the container that can hold the most water between two of these bars in this histogram. So a brute force solution, and you should already be thinking about this, is just to do a double loop. So we loop through every single height, we loop through every single integer in this list, and then for each of the integers that we loop that we're currently on, we have an inner loop in which we loop through every other single integer in the list, and we just calculate, and then we calculate the max area of all of these combinations, and then we return the biggest area among them all. So this solution would take O of n squared time because you have an outer loop and you have an inner loop, and that's the brute force approach. So that is the naive solution, and that isn't something that is too complicated. So our question is, can we devise a solution that is a lot more efficient, that we could just do it in essentially with one pass? We don't have to do an inner loop. So that is, so we'll be using pointers or counters. So we would use intermediate variables to track the max area. And what I'm thinking that we can do is we would track the leftmost index and the rightmost index. And then every single time we approach a bar that's bigger than the rightmost index bar, let's say we start with the left index and we hit this, and we increment the left index to this. So now we're currently on the second bar. And then we're comparing it with the right index. So for this particular problem, we don't even have to increment the right index at all, because you can see that the max area is the area that encompasses the one in index position 1 and the last index position. And you can see that the max area that this container can contain is 49, because the x, so this is 1, 2, 3, 4, 5, 6, 7. So our width is 7 and our height is 7. Very important to note that since we're trying to get the container with the most water, our water cannot overfill. So even though we start with the index position 1, it has a height of 8, we're choosing the minimum between the 7 and 8 so that the water does not overfill. So basically, by incrementing the leftmost index and comparing the size of the rightmost index, you can see that if our leftmost index is bigger than the rightmost index, we can keep, we don't have to worry about the other bars that are smaller than the leftmost index that we're currently on. So we just skip the first bar, and we can keep incrementing as going forward until we find the maxed area. But you can see that the maxed area here is already as big as it gets for this particular example. So maybe this example isn't the best one, but hopefully that elucidates the approach a little bit. So let's actually implement it. So let's actually keep our pointers. So let's track our left index and our right index, and also our max area. So our left index, of course, starts at index position 0. Our right index is the length of the list we're given, which they call height. So that's the list of all the heights. It's this text case, it's this input. And our maxed area is 0. So let's just call it 0 for now. And we'll replace the max area as we progress through the loop. So so while our left index is, so now we're just doing one loop pass. While the left index is less than the right index, let's track the width. So as you may remember, the width is always, it's just the x-axis. So it's our right index minus our left index. And let's also track the height. So this is kind of, so the height is, the variable name has already been taken over by the input list. So I'm just going to call this like height number. Not the most elegant, but it is what it is. So here's the brain leap. We don't want the water to overflow. So remember, we want to take the minimum of the left and the right index that we're currently on. So we're taking, let's actually do the left index here, and then the height of the right. All right, so, and then as you remember from grade school, our area is the width times the height, temp area, width times height number. So that gives us our area for the left and right index. And if the temp area is greater than the max area, we replace our max area by the temp area. All right, so now it's time for actually incrementing the pointers. So if our height of our left index is greater than the height of the right index as I said before, if the height of the left index is greater, then we don't increment the left index because let's start from at the beginning of the loop. Index position 0. The height is 1. Now we're comparing it to the height at all the way at the right, which has a height of 7. The integer value is 7. So 7 is greater than 1. So we would increment the left index by 1. However, if the height of the left index is greater than the height of right index, so when we increment the index position by 1, now we have a height of 8, and that is greater than 7. So now we actually have to decrement the right index. And then we shrink the solution set. We keep shrinking the container size until we find so we try for all those combinations as we shrink. And then if we find a temporary area that's greater than a max area, we replace the max area with the temporary area that's greater. But you can see in this example that all we have to do is just literally increment the left index by 1, and that would give us our max area for this particular example. But for the other examples, we may have to keep shrinking and shrinking until we find the container with the temporary area with the most area, or with the most water for this example. So we just we reduce this by I've been playing a lot with C++, so I thought you could do some kind of fancy post different, but I guess we're still in Python land here. So else left index. So else, let's say height. So just to really make it obvious, the height of the right index is, in every case when the height of the right index is greater than the left index, then we know we need to increment the left index by 1. So, and then we would just return the solution, so that's return max area. So yeah, so we have one loop. So in terms of analysis, what's next is out of range. So that's, so, oh yeah. Remember, the length of the height is out of range. We always have to, because we always start at index position 0, so we have to decrement the right index by 1, so we actually start here instead of the 1 over. All right, so this, we're having a wrong answer here. Our output is 8, and they're expecting 49.
Returning while in the while loop.
Yep. So we just have to do playing with Vim in leak code is not all right. All right.
What you're doing?
Yep. Yep. 49 is expected. So yeah. So for this particular input, we're just incrementing the left index by 1 because the height of the right index is greater than the left index. So 7 is greater than 1, so we increment from 0 to 1 in terms of index position, and then the loop keeps going through each of the possible solutions. So let's actually let's print out the temp area to see what the loop is doing. But in terms of, yep, you can see that the loop is shrinking the container size accordingly. If the height of the left index is greater than the right index, it's going to keep shrinking the container box. And then, but you can see that almost at the very beginning, the 49 is the biggest temporary area. So we're going to keep the temporary area as the solution set keeps shrinking, and then we end up with 49 as the biggest area. So let's also submit this. So the reason why they call this approach a greedy algorithmic problem is that because we're at each point where we find a locally optimum solution, And then we keep trying to traverse the possible solution space in the hopes of finding a global answer. So that's just a very fancy way of saying we're tracking a temporary answer, and then once we find, and if this temporary answer does turn out to be the optimum solution, then we can pat ourselves in the back. But if not, we're going to replace this temporary area. And for analysis purposes, because we're only doing one loop, instead of doing the brute force solution of two, of an outer loop and an inner loop, our solution is O of n, it's linear time. So yeah, and this is an example of a greedy problem. So yeah, any questions?
I have a question, Evan.
Yeah.
So yeah, obviously you started by highlighting the brute force solution, which if you try to submit it, it times out, obviously, on some of the bigger arrays. Let's say you never saw this problem before, you're in an interview, you never saw it before, and you're presented with this, you don't have the sort of fancy graphic that was in the email body that sort of just shows you the solution. How do you make the intuitive leap from the brute force solution to realizing that you can go, you can sort of take the bounds of this array and then step in, so to speak, and I guess skip over some of those brute force solutions that essentially like you're discarding, you're not considering them. Does that question make sense?
Yeah. So yeah, I would always recommend implementing the brute force solution first, because that you should always implement the brute force solution first with the outer loop and the inner loop. And then you can always, you always don't want to premature optimize. So always start with the naive solution first, and then think of ways of how to optimize the problem. So I think a lot of the intuition in terms, once you have the brute force problem, like the intuition I've always done is that if you always have an outer loop and an inner loop, and I've seen enough problems that there's always a way of doing it. Well, not always, but usually there's a way of doing it in one loop, but you have to use pointers. And so we use a left index and a right index here, and these are essentially pointers or counters. So, and then that's how you would exactly do it in one loop. So like I've just gotten that by experience, but in terms of trying to think of like an intuitive leap of logic in terms of making an outer loop, of trying to break down an outer loop and inner loop, I think the brute force solution is, you know that you're doing a lot of waste because you're recomputing things that you've already recomputed before. And what I would think, if I haven't seen this problem before, is that, is there a way of preserving, of knowing that, wait, this is the maximum area, like of drawing this particular problem out and say, okay, this is the temporary area or the container with the most water. And while I loop through the input list, is there a way of just realizing that, oh wait, all I'm doing is just incrementing the index position by 1, but I'm not decrementing the rightmost index at all. So I'm just preserving that order, and then I'm stopping at this particular point in time. And that's really what the greedy algorithmic approach is that forget about the future recombinations. Let me just step in this particular point in time. I'm starting with index position of 1. The max area is not going to be any big, but once I increment that index by another one, and now I can see that the max area is 49, and it's not going to get any bigger than this for the rest of the traversal of the solution space. So, is there a way I can keep track of that so that I don't have to keep trying to brute force and trying to find the remaining combinations for this area among all the other areas in the problem? Does that make sense? In terms of just like, okay, I've already found a locally optimum solution very early on. so I don't have to keep trying to make as many crazy combinations in order to find the maximum area. But I would say it really like comes with practice in terms of just realizing, okay, I have an outer loop and an inner loop. If I want to do it with one loop, I have to use some kind of pointers. I have to use some kind of tracking variables.
Can I also offer a suggestion? So one of the things that I think is super powerful about the solution is that you've basically broken it down to the area is the width times the height. And then you've created some sort of structure around how you're going about the width, right? You start at a maximum width, and then you start decrementing the width by 1 at each iteration, right? So if the width is only going down, the height necessarily has to go up, right? And so that's what the if statement is making sure that the height is going up. Otherwise, if neither of those, if the height isn't going up, you know that possibility isn't going to work out. And so oftentimes we're getting problems like this, and then it's sort of about playing around with the kind of values and trying to be able to fix one of the variables in a very structured way. In this case, it's the width, and then letting the other variable, the height, be very dynamic, and that's the actual thing where you're doing the map on the height. But your width is very much defined by the way you're solving the problem.
That was a pretty good explanation, Matt. Thanks.
And I also like, if you're in an interview and you don't solve this, like when you presented this problem, I didn't have an immediate intuition on how to solve it. And I don't know if you had like an hour-long interview, if there's like a definite way to get this. I feel like it's sort of, in the interview process, it's sort of think out loud long enough and say enough things out loud that they know that you can at least think about problems well, and then eventually they'll kind of guide you along to make sure you got to take the next step when you get to take the next step.
Yeah, and like in an interview setting, nobody is going to expect you to whip out like a linear solution, but they do expect you, or at least I would expect you to be able to at least whip out the n squared solution without much guidance. Like, oh, let me start.
The sliding window one, yeah.
Yeah, but let me start. Well, yeah. So like I'm starting out with, okay, in this equation 0, I have height of 1. Let me compute the area between this and this. Let me compute the area between this and this. And then as you keep, and then let me compute the area between this and 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 this. So then you should already be thinking, oh wait, that's just an inner loop. And then I'm storing all these temporary areas for my height of 1. But now let me try, let me go to the next height, and then let me compute the area between this and this, this and this, this and this, this and this and this and this. So like that is something that is expected for you to solve the brute force problem. And then once you solve the brute force problem, they'll probably ask you, is there a way of doing this more efficiently? And then they'll guide you with using tracking using pointers. Yeah. So that is the yeah. So that's the. This problem is very familiar with the. So let me.
I was gonna ask, is there like a name for this strategy? I just feel like I've done this in more than one clean code problem.
Yeah. So this is literally the first problem LeetCode is the two-sum problem, and you can see that the brute force problem is always the outer loop and the inner loop. And then, like, as you make it more efficient, now you're using like hash tables, and you're doing it in a one-pass hash table. So you're just doing it with one loop. And there's a mathematical trick where you're tracking the diffs and then storing it in your dictionary, and then you'll be able to do that in O of n solutions. So that's like the. So every time we try to find out a way of trying to make an O of n squared solution to an O of n solution, it's really using trackers. So the two-sum problem uses the dictionary to track your differences, and for this problem of container with most water, it's just using the left index and right index variables as like a mini dictionary. It's not really like, but it's just a way of keeping track of your most efficient points at that particular point in time. So I would strongly recommend reading more on the greedy algorithms. Greedy. I used to work in finance, so I'm a big fan of these. But yeah, that's it. If there's no other questions for me, I'm gonna hand it off.
Evan, I think you had a question about like what type of problem this is.
No, I was just asking because like sometimes I feel like with lead code, in order to, the only way to learn them is to kind of like do them, and then you just kind of start noticing the patterns that apply to maybe more than one problem. And I feel like in this case with the pointers, keeping track of the left index and the right index and only incrementing one of them, it's like a common strategy for lead code problems that you might encounter. It's worth just like knowing the strategy, I guess.
Yeah, exactly.
Yeah, I found that a lot of this stuff is just good old standardized test cramming, and just do a bunch of these. Eventually, you just start seeing them. This is a finite field of these kinds of problems that they can give you. They'll change around the the details of it, but the problems they tend to give you are within a specified set.
Yeah, it's really, there's really just practice using, it's just really extensions on core patterns and algorithms and design and data structures. So once you do enough of these problems, if there's a novel problem, you're just really extending a core data structure, algorithm, or pattern in a different way, but that's typically all the problems we've done so far are typically just extensions of classic patterns that are tested over and over again in lead code.
Emily, can I ask you a quick question as well?
Yes.
So I just started studying the data structure and algorithms, so I'm really a junior level, and then I started a lead code problem as well for the very easy ones. But my concern and then my difficulty is that like when I read the question that I cannot, maybe I'm not familiar enough or I digested the concept enough, so like I cannot think about what strategy to come up. You recommend to practice and then see the solution first, or like just like take some time and then like dig into like find a solution as much as possible. What is the like most efficient way that I can achieve this in a very short time?
Yeah, I would say practice for like 15 minutes, and if you don't know what to do, I would just look at the solutions.
Mm.
Yeah, because a lot of the solutions are just because these problems are not novel and the solutions are well established in terms of using an already proven algorithm or data structure or pattern, but just extending one of those classic patterns. So when you look at a solution, you actually will be learning if you haven't seen it before, you'll just be learning one of the classic approaches, and then you'll see them how they squeeze it into the problem. So I would just look at the solutions after like 15 minutes.
Okay, good.
But then I would keep it in the backlog and then like review them like after a week from scratch and see it if you remember the pattern at hand. Yeah.
I see. Okay.
Yeah. But yeah, that's the. So let's look at the solutions here. Wow. Wait. Okay. I didn't realize they have a solution in LeetCode for a pre-written solution. So not all LeetCode problems have like a pre-written solution, but this one does. So okay. Yeah, it's very similar. Max area equals max area, math.min height. Yeah, yeah. This math.max is just like that's cramming way too much stuff into one line. So I prefer my approach of, I think it's a lot more intuitive that the temp area is literally just the width times the height, and the height, and just seeing that the height is the minimum between, we don't want the water to overflow, so we want to make sure that the height is the minimum. So you don't have to worry about taking the max of a min. It's just like, I think the solution is not very readable. But here it seems very similar. So yeah, so as Evan said, there's always a brute force naive answer, and then there's like a way of doing it in one loop. And by doing it with one loop, you always have to keep track of using pointers, which is a fancy word of like, like as I said in the first problem of LeetCode, it's like the two-sum problem. And the two-sum problem is literally the same exact pattern of keeping your solutions. The brute force is always outer loop, inner loop, and then the most efficient solution is just keeping your answers in a dictionary, which is essentially keeping pointers. Is there anything else?
I'd want to touch on that a little bit. So I think if there's like two different hurdles that you might be having trouble with. One is like coming up with the brute force solution, and the other is coming up with the optimal solution. And if you're having trouble coming up with the brute force solution, I think the problem might be the language. Part of like getting used to computer science and software in general is like learning how people phrase problems. And so I think if that's what you're having trouble with, I would definitely be looking at the solutions and even try like going the opposite way. Like take an algorithm and try writing it as a question. And I think that might make you more comfortable with how computer scientists think about these problems and how they word these problems. And then if you're having trouble with like coming up with the actual optimal problem, honestly, that just sometimes just takes an epiphany, and there really isn't a clear answer to that. And so I think wrestling with the problem is oftentimes, like some problems you wrestle with for a long time. Sometimes you come up with a solution very quickly, and so like being patient and having like lower expectations, I think is definitely helpful, because we see Edwin kind of come here week over week, come here and present a solution. But a lot of these problems, if any one of us, even the senior engineers here, were kind of taking it off on the first time, it would take us the kind of like eureka moment. So I would definitely make sure to have like, don't think that you need to be solving these problems immediately or having like, oh, I know exactly how to solve it.
Yep.
Good point.
Yep, that's it for me.
Okay.
Thanks, Edwin.
Yep.
And so we brought this up earlier, but we made a playlist of a bunch of Edwin's lead coding things that he's done week over week. So if anyone kind of wants to go through them, they're on the Coding Guild's YouTube page, so definitely check them out if you're enjoying this. Next, we're going to go through a discussion. But before that, I thought it might actually be a good time to kind of talk about topics that people have brought up. Not because we're going to do a topic right now, but kind of because I think it might be a good thing to bring up where these kind of topics fit in the broad scale or the broad sense of a coding journey, in the sense that like where does dynamic programming or where does big data kind of fit in? Like, should you be thinking about these things very early on? Should you wait until you kind of address these later on into your journey? So let me present. Okay, so this is the spreadsheet of some of the ones we've gotten. Going forward, definitely kind of keep us in the loop if you want things to talk about. But I think it'll be a great place to kind of refer back to in the topic of the conversation. I'll actually paste it in chat so that we can kind of refer back to it. So we refer to what our list is. So the Unreal game engine. So this is definitely an Edwin suggestion. Keldo was actually last week's topic. This is what Harmon brought up in the service that he was recommending for developers in Mac. Microservice is like a software architecture paradigm strategy. Big data is a buzzword for like all that's like anything with a large amount of data. Front-end development, anything that's like a UI thing. Cloud with a specific request for serverless. Serverless is basically if like if you know anything about functional programming, it's how you apply pure functions in the cloud. Terraform, I can't really speak about that, but these are kind of like DevOps tools, and more importantly, there are software strategies. Harmon, do you want to touch on Terraform?
Yeah, it's basically infrastructure as code approach. So you build all your infrastructure, servers, databases, and like DNS entries, storage, anything using code. So like you can like track different versions of your infrastructure. You could roll back your infrastructure. You could see historical changes made to it and all of those things.
Thank you. Developer tools, I think this will be a great topic at some point, but it's also a very wide topic, like what developer tools to use, and when to kind of start thinking about like using someone else's developer decisions for developer tools, and when you can kind of start doing your own developer tools, main work for side projects, social topic, coding in African American communities. This was a response to kind of a lot of what's going on in society at the moment. And then data structures and algorithms, how it's applied, what's important. We'll definitely touch on this in this conversation as well. Like, at what point does data structures and algorithms start to become a more and more important thing? It's definitely a thing that gets asked on a lot of interview questions, and I think it is important, but I think there's somewhat of an overstatement in interview how important it is. We can kind of debate that today. Django, Flask are Python-based server languages or server frameworks. Databases, particularly NoSQL ones, it's just a tool for storing data. Hadoop Spark is a big data tool for processing a lot of data. Deployments, particularly in Heroku. So this is like a topic of like when to start addressing cloud problems, and then various ML AI algorithms. System design for software developers. I think this is definitely something that I'm going to want to bring up at some point, like when to start thinking about when is system design like a relevant thing. I think as over time, it becomes more and more important to start thinking about these things. And this is kind of what I attribute senior engineers supposed to do, and I'll say more about it when we kind of talk about it. This was a tool that was recommended from someone. I think it was a question related to work, and I think it's a little bit more specific.
Oh, that's for Z.
Okay, well, we can kind of come back.
Yeah.
Machine learning debugging, that's an interesting one. Vixio, that's, I think it's a competitor to Pandas.
Yeah.
It does something with a more efficient memory transformation. Then recursion and dynamic programming, which kind of fit in the same realm of like data structures and algorithms, and graphs are also in that realm. Right, so these are kind of all the topics that people have thought about or have wanted to kind of start learning more. And we're gonna hop over, am I sharing the right screen? Yep. To kind of talk about the coding journey, which I think is, again, the reason I suggested it as a topic and wanted it as a topic is because as I'm building out my course content, it's something that's super relevant. What is the most important thing for people to be learning first? And so there's sort of like the junior, the mid, and the senior end of things. And kind of just started off, I'll kind of talk a little bit about how I think about it. And I think generally at the beginning, the junior end of these things is like, how do you execute code? And I think oftentimes this is code. This is oftentimes like an understated thing. I think a lot of times people just kind of jump into trying to study like an advanced machine learning model or study like, like you hear big tools like Hadoop and whatnot. And I think like going back to the fundamentals of like, what are the fundamentals of programming? When I think of the fundamentals, it's literally like coming up with, like figuring out how to execute something, figuring out how to run a program. And oftentimes this is actually something that can be a big problem. And then like the other thing that I like to think about is, I just had it on the top of my head. Like being hypothesis driven. And I think this is like a big hurdle for a lot of people. And I've often seen people, when they start to program, they'll write a lot of code. They'll write like dozens of lines of code before they actually run their environment or they run their code. And I think that often leads to bugs, that often leads to like very complicated debugging. Whereas if you're kind of hypothesis driven and you're like, okay, what if I change this one line of code? And I come up with the idea of how it's going to affect the code. And then I test that hypothesis, right? Then I have a lot less likelihood that there's going to be bugs in my code base. And I also think that it's going to have, you start to be iterative. And this is actually why I think Hello World is most often the first program you do. It's because that's basically the easiest program to edit a very little amount and then see the result of it, right? So you can change Hello World to hello in your first name, and that is you changing the program. That's you being hypothesis driven and kind of taking the next step. So does anyone have any kind of thoughts on these that they want to share about what they think, either these two topics or other things that they think junior engineers should kind of be thinking about in their journey? Anyone?
Yeah, I just had I don't know, I was going to mention this debug deep learning model. And what I also meant by that is for making that clear, is I also wanted to know how to like optimize it. Like, what should I look for? The model is running. I get some results, but now I have some accuracy. And but what tweaking can I do, and how can I do that? So that's just a question on what you said. Hello, can you guys hear me?
Yeah, we can hear you. So the kind of question is how to, like, once you have a solution for a machine learning problem, how do you start iterating on that? Fleet would probably be the best person, but I think, I have a few thoughts.
I'm just gonna mute myself because there's a lot of sound, but I'm listening. Good?
Sure.
Yeah.
So, like one of the things I like, you don't want to optimize your machine learning program too much, in the sense that if you start trying to get a better score on your test data, you might not necessarily be coming up with a better algorithm, but an algorithm that is more optimal just for the data you have. And so oftentimes just doing these kind of small tweakings, one of the big concerns is that your, what is it called? when you're too optimized for the testing data set. I'm blanking on the term.
Like overfitting and stuff.
Overfitting, yeah.
Yeah.
So that's kind of like a concern there.
Yeah. It's just that the problem is like I use the group search CV or SV something, in which I can give it different parameters, and then of course you don't want to give it like too many parameters, so it's gonna take like a really long time. But that's still me giving the model some parameters that it may or may not improve, but I have no indication of where to go with it. So that's kind of like my issue.
I think what might make a better conversation around that is if you took the time to kind of present on your model, and then we kind of went around and kind of shared our thoughts on your solution and where you can kind of take it from there.
Okay, sounds good. Thank you.
Okay. Okay. Evan, or were you going to say something? Sorry. No? Okay. Yeah, so I think, yeah, then kind of touching on like the mid-level of software engineering, I think it really is kind of around this kind of data structures and algorithm side of things. And so I kind of think like, what is the hurdle that you kind of hop between being a junior and mid, where you kind of start focusing on these data structures and algorithms? And for me, the kind of milestones are around like, I think part of it is like you should somewhat feel comfortable solving like a brute force for these leak code solutions. I think is kind of like a good milestone when you want to start thinking about, okay, if I can come up with a brute force solution, now I want to start thinking about data structures and algorithms and kind of take the next step to optimize for that.
Are we talking about kind of like expectations then? I guess for like someone trying to get a junior level role?
Somewhat around like, so what is the problem I'm trying to solve? The problem I'm trying to solve is that there is so much in this space to be learning that it's oftentimes hard to kind of figure out what you should be learning, right? Even if you kind of think about this big topic list that we've come up with, there's 30 different things that you could be learning, right? And so how do you kind of figure out the next thing on your to-do list without being overwhelmed by all the things on your to-do list? And so this thing that I want to solve is kind of giving a little bit more direction to kind of the different levels, and then saying that, okay, here is where you should start thinking about like the next thing, right? So like one of the things I would say is that oftentimes like microservices is a great buzzword, but I honestly don't think you need to start thinking about microservices until you start to become like a senior engineer. And I think oftentimes people, like everyone's talking about it, but at the end of the day, like you can be very productive in an organization without knowing microservices. So is it the best use of your time to be doing it this early into your development? Is sort of where I'm kind of going on.
Well, like knowing DevOps, right? Is DevOps really that crucial? Is that what you're saying for a junior developer?
Yeah, like at what point should you start thinking about these things and start reading into these things? And kind of just allowing people, saying that, like, okay, while you're still junior, you can kind of skip over a few of these things and not worry about them so much.
I don't know, man. At least in the data space, I see like at least mid-level positions, often even junior positions, asking about like familiarity with like AWS and like microservices necessarily, but definitely like Docker and some of those things might be important.
I would definitely put Docker in like the mid-level. Yeah, I mean, I guess. Sorry, Harmon.
Yeah, also like something related to databases, SQL, all of those things. Like you should have like knowledge of SQL, NoSQL. That should definitely come maybe in junior or like mid-level for sure. Like you should have like at least like uh, like beginner level knowledge if you're a junior about like how to write like SQL queries and all of those things, and then going on to like mid level like how you wanna like which which database engine you wanna use, why you wanna use a particular language, how you wanna write queries, all of those things, how to like optimize your queries. A lot of those things comes in like specifically like for a backend engineer, because like once we like I think all of us have seen like data structures and algorithms is just part of the like interview. Like once we start working, we hardly use like 15 or 20% of actually what we write when we write code. So mostly like more rest of the part is like 50% of it is mostly working with databases and a lot of like different data techniques. So that becomes like most of our day to day. So yeah, definitely something like knowledge about all of those things.
I feel like they have a good way of defining these different levels, or is that even kind of like a superfluous exercise?
Yeah, so like different levels, like it could be like or like just junior level, like how you you have like how to like run your like migrations if you're adding a new column, and if you're new to like how to set up a new column onto a database. That's one thing. Another thing like basic, like if you want to look into like DevOps, like how you create permissioning, how you create users, how you create roles, how you grant privileges, and all of those like different things are related to like your database table. um, then going on to uh, like uh, like mid-level would be like more of like transactions, your queries, how you can integrate those queries within a code, how you like set up like joins between different tables, how to set up like different keys, calling of like new tables, how you decide when to create an index on a table, how to how you decide how to your particular like database table is growing, how you decide on like splitting that up so that you could like optimize your queries, all of those things. And then also like deciding like whether you need a SQL database or you need like a search engine, something like Elasticsearch DB, or maybe like you need like NoSQL like for MongoDB, where just you don't have like a one-to-one relation or something like that. So that's like all like mid-level, senior level stuff.
What would you consider like advanced? Oh, okay. So you said let's make the senior level. What do you think like senior level DevOps is? Is that like Terraform and Ansible and all of those tools?
That's like for DevOps, like Terraform, Ansible, all is like mid-level, senior level. You should have like starter, like you should have basic knowledge, and then you could like custom scripts and all of those things. You should have like senior level, like you should have like knowledge of how to like set up like your CI/CD pipelines, bringing in like different tools like Jenkins, Circle CI. You build a like deployment model.
The CI/CD a bit earlier. I think it might be a lot more relevant towards a lot more code bases than even Terraform or Ansible. I'd be curious where you would also kind of put Kubernetes in this kind of like.
Kubernetes.
I know it's like a.
Kubernetes is like senior like architect level stuff, and mostly falls on like DevOps part, not just like related to like like anything like for software engineering or anything, but more on DevOps side. Plus, like for mid-level and like junior level, like you should still have like basic knowledge of Linux and like different processes. Like you should know like general Linux commands if you're running your code on a particular machine or VM, Docker container, whatever it is. How you see like how much the different resources your particular code is taking. You don't want to like run out of memory or stuff like that. Like your code shouldn't like spike the CPU and crash the whole server. So all those basic things.
I think Bash Linux is like one of those things that definitely like crosses a lot of levels. I think very early on, like learning CD and change directory and like LS is like that's like one of the first things you learn programming anywhere. But like if you know how to do a for loop in Bash, like I've never done a for loop in Bash. Like the basic commands come up so frequently, and then like the like Joan, Joan, like the
like changing like directory permissions, like grep commands, your awk command, like simple Linux stuff, which would like help you like move around in like your own like local directory or your like server directory or whatever it is. So like just basic commands so that you can get through. So yeah, if you know that at junior level, it's gonna be good, and then you can like move around, learn more, go from there. Yeah, so I think and then like when you come to senior level, like you should have like knowledge about like you mentioned microservices, but you should also like do like microservices and monolith, because not a lot of like people like still like are on monoliths, and I don't see like a huge advantage if your monolith is working perfectly fine. Why do you want to move to microservices, right? So like that's always a debate. It depends on your like on your team, on your infrastructure, on your like code, all of those things.
That's a great topic. When should you move from monolith to microservices?
Yeah, but when you should like when to move to microservices, or why to just stay on monolith and all of those things. Because with microservices, there's like a disadvantage that there's a lot of overhead. Like you have to manage so many services, which are like split up. Like you're splitting your one code repository into like 10 or like maybe 15 different services. So you have to set up monitoring, maintenance, logging, a ton of stuff for all those different services. Whereas for your monolith code, you just had to do like one setup for each. So that's how it depends. But like moving to microservices, it's like you're breaking the dependency from one code, right? So like in different, like one code split up into 10 small services, totally independent of each other. You could move around. It gives you more flexibility to work with your code and a lot of those things. So that's like you have to like discuss, decide, and see what the benefits are going to be, or like the like drawbacks and all of those things.
Yeah, thank you, Armin. I think that was
and like in a for senior, I think there should be like security best practices. Whatever you do, like if you're writing code, you should try to write more like the most secure code. You should like have like put in like your passwords in your code, just to like when you're like, just for like a lot of people have this habit, oh, this is just my dev environment, I'm just gonna put in passwords for my particular code. It runs fine, and then after like 2 days, people forget removing that code. They share their passwords, all of those things. Same as well.
So that's actually something that I would put on a junior level, like removing passwords from code is like because it's very easy to forget. And I've seen it across organizations, and I've seen it like You're like surprised when you see it, and you're like, hold on, this doesn't look like a random string. This looks like it's a passcode for something. So,
Like along with like you just gotta like keep upgrading versions because over the time, like especially for open source stuff, like there's like a lot of like new upgrades, new versions because there's a lot of like security patches. There are people out there who just like wanna break open source stuff. So like people who don't upgrade, maybe they like have this like something over the time, like there's a gap of like maybe some security loophole, like people can get into your code, maybe inject stuff, or like get into your database, leak some like sensitive information and all of those things. So yeah, there's just like few of the things you gotta learn over there.
Don't be
yeah,
Equifax.
seriously. What was that, Andre?
I said, don't be Equifax.
Oh, yes.
Yes. Yeah.
Open ports, outdated software.
Open ports, yeah. If you're working with Docker containers, you like have open ports, you have exposed ports. You wanna like test some stuff, you forgot to like close them out. It's just like a idle port listening to something. Someone can just like DDoS that port and bring down your whole service. A lot of those things keep going in after that.
Also under senior, I put optimization, just at various levels. Whether that's rejiggering a whole system to eke out some performance, or whether you're messing with kernel level stuff to get more performance out of a stream, whatever it might be. So I would put that there.
I think there's optimization that's like a big O optimization is sort of like a mid-level.
Oh yeah, big O. There. Yeah.
Whereas I think what you're talking about is like really knowing your technology well enough to the point where you're understanding things that like, you know, where you're the expert in the thing, the organization, and you're optimizing for it.
Yeah, at that point you're messing around with your Linux deployment, because like the most software comes with sensible defaults, and those sensible defaults are no longer sensible when you're using the machine for a very specific purpose. At that point, there are much better settings you can use, as long as you know what you're doing. And I feel like that comes at the senior level.
Yeah, I would definitely agree there.
Yeah, and also like for like senior, like you could like, you know, like if you want to build up a like caching layer for your stuff, so when to decide, you don't want to like hit all like your queries should hit your databases, when you want to like bring in a caching layer and all of those things. So yeah.
So I would put cache busting as like the senior thing, and just caching into those like the mid-level thing, in the sense that like caching is a great way to optimize your code, but then you lead to some bugs that are like having a good caching strategy. I think is like one of those like I think there's like a quote about regex like, oh, if you have a problem, use regex, and now you have two problems. You know, like I think the same thing with cache busting, right? Like it's a great solution until it's not, and then it's a huge headache.
On a non-code point for senior engineers and higher is managing difficult people, including PMs and non-technical personage in your vicinity. I think when you become good enough to do all sorts of stuff in the company, you start wearing non-technical hats as well, and you start becoming, or you start morphing into a more you start slowly morphing into what a CTO is, and that's where you start coding less and less and start managing business people more.
So
negotiating that relationship between the rest of the team and the business.
So you become like a product.
That comes at the tail end of your experience, I think.
That's true.
kind of accepting the
Uh,
reality.
you're basically morphing out of a senior engineer or architect into more executive technology roles at that point. If you want to, you don't have to, but if you want to, that's the next step.
They gotta learn how to dumb down things. You know it the smart way, but you gotta learn how to dumb down things for people who don't know.
You just tell me
That I think is the senior level, right? Learning how to that's the Einstein quote, right? Like if you explain it simply, you like really understand things.
How do you explain hello world to salespeople?
Just tell them you're using hash maps.
That hash maps joke never gets old.
They will never get old. No.
But yeah,
Like at senior level, you could put in like system and architecture design for new projects. That's mostly done by architecture level, like which language you want to use, what front end you want to use. You want to create a new database. You want to put in like caching, like what server you want to put it on, like server design, all of those things. So mostly like system and architecture design is done by senior team leads, architects, all of those things.
Another slightly non-technical point, senior engineers should, at a certain point, become able to build a technical team. So I have a project, I don't yet have a team. What do I need, right? Who do I need, rather? So whether that's
Figuring out
resources from your own company, obviously you'll have help from human resources with the more logistical points on this, but they're going to look to you to tell them bullet point wise what qualifications you need to get this thing done, since you're the technical lead.
like starting a project from scratch, right? Because I think that's like a very important hurdle in the career of someone, but it's also something that's like super daunting to do initially the first time around, and then eventually kind of get super comfortable with it.
I mean, what I've seen with various senior engineers is that they generally have a bunch of templates and stuff lying around that they've accumulated over their career, and that they just sort of apply when starting a project from scratch. That tends to make it less daunting because you at least have something in front of you to start with. But I think that only comes with experience.
Say that the first time you start a project from scratch is like that hurdle between junior and mid. Is where you really like you see how many decisions you can make in coding, and you can become super intimidated by that. I know I definitely did first time around. I still do, right? There's so many decisions to make, and so like when you hop into someone else's code base, you're like, okay, here are the paradigms they're using, great. I'm just going to implement it that way. But when you get to be the person deciding these things, I think it becomes super hard to actually make a decision on these things. And I think getting firsthand experience on that is super important, especially when you're going all the way from like starting a project to like deploying it and making a live API or whatever.
Yeah, to that I'd say it's it's, in my opinion, good to make mistakes fast. So don't get too hung up on decisions, especially since there are so many. Just be wrong and feel the effect of your wrongness on everything, and then you'll see, oh, maybe I should have made the other decision at that particular juncture because of X, Y, and Z. And suddenly you have something you can use in the future, as opposed to remaining stuck on that decision point for a long time, and that doesn't yield you any benefit. So
yeah, I think that's a great point. And actually, I think the more advanced version of that is learning when to change a mistake and learning when to accept a mistake. Right? There's so much refactoring that could be done, Like sometimes you're just like, okay, like yeah, it sucks that we picked a bad technology, but for now we're accepting it. Or other times you're like, no. Like, okay, yeah, it sucks that we spent a month using this tool. It's gonna take another month to undo all this work, but we have to do this.
Yeah, for that, I wanna suggest one thing that you should like always do like POCs with top 2 or 3 technologies. Uh, it might just take like bit more time than you actually picking up this one technology straight away, which you know, or something like that. But going like in the longer run, it's really going to benefit you a lot. So in that case, you just like pick up like top 3 technologies, compare their pros and cons, build a like minimal viable product, share it with your like teammates, show it to your seniors, and then like all of you like all like the stakeholders, you get in a room and just pick one. So like uh, it could be depending on a lot of factors. For instance, like you pick one technology, like you decide to code in Python, right? But like there are like 5 other team members who don't know Python, and the rest everyone just knows like Scala or like PHP. So picking Python would not be smart in that case. So like you like just like pick top 3 things, decide, discuss, do a POC, and then get onto like one final decision. So like bringing in all stakeholders and all of those things. That's more on more on like the management part and less of technical stuff. But when you're a senior, you should do that. You should have like the tech knowledge where you like build the POC with the technology, and then you should also be able to tell that to other people on the team who are not that good with that particular technology. Like maybe convince them, okay, these are the advantages if we use it. So yeah, that's like a way of like tackling these situations.
Yeah. Okay. I mean, I think this has been a good discussion so far. Unless anyone kind of wants to hop in and share some more thoughts, I think we want to kind of transition over to going through the topics and talking about what people kind of want to hear going forward. So I'll give like a minute or so for anyone to kind of say more.
Oh, actually, what about the product manager? Where he would come into play with where just everything that you guys just mentioned right now?
I mean, I think it's it's a different role, right? So in the sense that like we're talking about an engineering role, a product manager is essentially an organizational role that is like the intersection of a bunch of different pain points in organizations, right? That's like communication pain points, that's like prioritization pain points, and all these things. And really the purpose of that role is to basically like clear blockers and make it so that these pain points are minimized in some way.
Basically, you just make the product manager feel a little bit important and then wholly ignore him the rest of the time. I'm joking, of course. They're nice. They're wonderful people usually.
No, but I thought of them when you were like when you guys were talking about like trying to explain like coding to people that are not very technical. So I thought that's where a product manager would come to play and like
yeah, I mean you're gonna have to interact with PMs because they essentially occupy the space between yourself and the business when deciding the future course of what that business is producing, the products. What are you going to be selling essentially or putting out there? So
Wow.
they occupy that niche where they understand the business, they have some understanding of tech, of what is possible at a very high level. Like, oh, I've seen this before, I've seen this other thing, maybe we can create something similar for this situation. And they talk to clients, potential clients, they talk to, or they're supposed to at least get this understanding of what clients want and what the business wants,
Mhm.
and then propose a product or some feature set that we're going to build and sell.
Oh.
And so, yeah, basically what they need from you is telling them whether or not stuff is possible, and also they're going to really want timelines out of you for everything.
Right.
And that's where things get really hairy, because there's it's extremely difficult, if not impossible, to tell someone exactly how long something is take if you haven't done that exact thing before.
Mhm.
And it usually is the case that you have not done that exact thing before, because the space is so huge. So
Definitely.
yeah, that's where you.
I think that brings up Kanban versus Scrum.
Oh yeah, the ineffective organizational method versus the other ineffective organizational method.
Yeah.
I think we should try the method where everybody just gets in a room and screams at each other for half an hour, and then goes to work.
You're going to be a Barry.
No, that's when we all get in a room and we're terrorized by one person.
Yeah. Prod is down.
I don't like being terrorized by one person. I like the pure chaos situation a lot more.
Yeah, the terror should be democratic at the very least.
Yes. From all according to their ability, to all according to their nerves.
Okay. Yeah, I think this coding journey is definitely helpful for me. I hope it may have also been helpful for other people. In hindsight, based on how many people have kind of popped out of this conversation, maybe not the best topic, but I definitely enjoyed it. What I want to kind of do next is kind of talk about the topics that we're all kind of brainstormed, and then see if we can kind of come up with what the next step should be, or what should like what the next coming topic should be. I don't know. I feel like most people left. I wonder, like, one of my questions is like, can we have a discussion around microservices, or is that sort of just going to be like a few different talking points, and then not a whole lot of substance?
I feel like it's probably too high level. Like you can definitely get most of the information out of that from just a little bit of light research on your own. It'll give you the big 5 pros and big 5 cons about it, and you get a good idea of how that works. But if you want to do something related to I don't know, like RPC versus REST, right? That's a little bit lower level, and maybe you can even have like a small demo of, hey, look, this is how you build an RPC API, based API. Like, I don't know, maybe you do gRPC specifically. I would find that useful, more so than, well, I'm also at a different level than people, than some of the more junior people. So for me, I would be snoozing during a microservices talk probably, unless it's just some revolutionary content there that I haven't heard before. But I would be a lot more engaged with something like talking about, I don't know, network interchange or something like that.
There's definitely a lot more detail that people can do. The other one, like another one that I think is interesting, is developer tools. I think it'd be interesting to kind of see what everyone's like favorite tools are, having that conversation. But it's also like sometimes like at what point should it be its own lecture, right? So like one of the ones that was I made a lecture on Postman. I think it's a super powerful tool for people to use, and I thought it was very appropriate as its own thing, right? But a conversation on VS Code for Spin maybe can kind of be grouped up into some other code.
See, with something like this, so I also, I mean, you had your talk on Postman, and I talked about Python, and then I touched on some other tools as well. I think this can occupy, it's a personal opinion, this can occupy like 10 or 15 minutes of rapid fire like presentation of something, and that's everybody sort of pitching in, giving their one or two most loved tools or something like that. As long as we don't devolve into Vim versus Emacs, I think
that is a generational question. I think a generation of programmers ago would have had that conversation.
My answer to that question is neither. Don't do it.
Yeah, exactly. We've passed that.
Hope I haven't offended anyone, but yeah. Yeah, I feel like if everybody presented one or two of their favorite tools that they're most passionate about, I think that would keep the energy up during when talking about such mundane things as tools.
I find it interesting, especially if like kind of figuring out what like the ideal developer workflow is. I think like an interesting challenge in the sense that like there's so many decisions you have to make, and if I can outsource some of these decisions to someone else who knows more than me, or who like has picked up a bunch of tools that they find super useful, like God bless, it's one less decision or a dozen less decisions I have to make.
Yeah, I mean, for me, it's like what tool makes me feel good inside, or what set of tools, and it's just like, oh yeah, that's what I'm gonna use from now on forever. And it's hard to dislodge that once it happens, but yeah, you basically need to one, go through recommendations, to actually use them. So.
I mean, looking through a bunch of these, I feel like a lot of these are more presentation topics than they are discussion topics. I know the social topic is a good discussion topic. What else is there? But most of these, like Django Flask stuff, that's a presentation. Maybe the debate of which one to read is a big discussion. In databases, Group Spark, machine learning, like all of these are kind of presentations. System design is like, maybe this one's something that can be a discussion, but it's also like almost too high level to kind of be a thing. And then we have requests for like dynamic programming version, some tools along the way. I don't know. Anyone have any strong preference on what we do next week?
Whatever happened to the build the Peloton data infrastructure project, or like Python infrastructure project?
I haven't got Ibby on it in quite a bit. I think the broader thing that kind of is take a problem that any of us are dealing with in our workplace, and then as a group solve the problem. And I think if anyone was willing to kind of effectively lead and project manage that would be a fantastic conversation.
I would suggest you guys can build my stuff, but I only just started in a new company, so I'm still learning what they have. So if someone else needs to spend their company's work as like free labor to the group, or get free labor from the group on anyone else's company.
Yeah, and go to your management and show how much knowledge you have. Yeah, I think actually we haven't done that yet, and we've talked about that since we were even doing this in person. But we talked about take a broad problem like Google search or AWS, and let's talk about how we would implement that. Yeah, I think that would be a good topic for next week.
AWS.
But that would be like system design and all of those things. Do you think it would be
Yeah, is that,
a level?
so my concern about high level is that after a while you stop having things to talk about, and so if there was like a quote unquote project manager that would kept driving out discussion points and like coming up with random limitations or whatnot, like say we came up with AWS quote unquote, and they're like, okay, but let's say we build it like this, and there is a lag in connection. Right now, how do you start debugging that, right? And then it can kind of keep driving out problems for us to brainstorm solutions for. And then I think it'd be interesting to kind of see how other people think and what potential places they want to for solutions.
So I kind of like the AWS idea, since there's a lot you can do with that. I mean, if we wanted to start like a Coding Guild AWS account, we could do practical things like Harman could go over like, okay, how do we provision users in that AWS account for all the Coding Guild members, and how do we give them permissions? And that's would be a simple thing to go over. Maybe I'll set up like a I don't know, like a data stream into an RDS Postgres. Hopefully we can keep all of this within the free tier. But
Yeah,
and
yeah,
then
if anyone wants to do it, like I can do like a whole AWS course.
Wait,
and then you can take that.
Guys. I thought the idea was, what if we
Build
set
AWS.
up AWS itself from scratch? Right now, it sounds like you're talking about best practices when using AWS.
How to set up AWS itself from
Like,
scratch.
what if I wanted to build an AWS competitor? So I need to re-implement AWS on my own machine.
Okay,
Oh, I
so
see.
you just want to like build a cloud version of your server sitting in data center.
Yeah, not just a cloud version of my service, but yeah, like I want a system where I can give users like INS or AMS accounts or whatever they're called, and users can spin up their own kernels, and users can schedule their own systems to run and have reliable access to however many resources they provision. So we wouldn't necessarily have like big engineering systems running this, but just the have all the framework in place based on our tiny amount of compute like on our laptops.
So I have like this idea where the underlying machines. I had this idea like a while back where your underlying machines you could just take like you could put servers on AWS, and then you can like set up like basic containers on top of it. And then people like there are like a lot of people out there who don't require a lot of compute, just need like a small compute for their dev environments and everything. So they can just come in, build their own sandbox, and then like just pay by the hour. They can cut it off like after 10 hours, 6 hours, 2 hours, stuff like that. On a single machine, we would have like 10 or 15 different dev hours, each split up into like different containers. And that's that. And they pay us by the hour. I had this idea like a while back, but don't have time to build.
Yeah, so that's just setting up like a miniature AWS, but from like hosting it from your own machine.
Yes.
Maybe we're talking because they would need to be able to set up their own environments that they log in and log out of, and when they log back in, you need to be able to like reconstruct the environment they had. And then when they log out, you might want to free up the memory so someone else can log in. Yeah, I think we're talking about the same thing.
Yeah, exactly, like something like that.
And they need to be able to create like accounts, and they need to be able to have like databases and I think the exact same thing. Do you want to work on that? we should have that be like the group project. We need to start out by designing it.
Yeah, like I'll be happy to do it. It's like there's nothing of that sort out there right now.
Well, there is, right? That's Amazon, that's AWS and Azure and Google Cloud.
Yeah, but they haven't open sourced their code base for how like someone else could deploy their own AWS clone.
Yeah, they haven't, but it's all the alternative because every in-house is not. You can call it like an internal cloud is just basically getting a bunch of servers and then just doing some networking. So that's why people are not making AWS clones. They're just having internal clouds. Does that make sense?
Yeah, so I don't actually think it's like a great money-making endeavor because Amazon has so much engineering and tooling behind AWS that it's hard to be like recreate all of it to the point that someone would want to learn how to use our system. I think it would just be a really good engineering learning experience for myself and hopefully some others to figure out how to set up these different pieces.
Yeah, totally agree.
I don't think you would. I think you would also learn something from setting this up, right? It's not something that you can, in your mind, know exactly how it would work just by like thinking about it briefly.
Yep. I like the idea, and I really like the number 3 idea on the spreadsheet too. So if anybody. So
Unreal Game Engine.
If they're building a game engine.
Oh yeah, that's my number 1 choice here.
Yeah, that's my. I just want to stress that's the thing I've been working on, and I like that's my number 3, and we can do number 8 in conjunction, but number 3 is for me that's my number 1 forever.
Your number 1 forever changes every 3 months.
Yeah, I mean, but like figuring out how to write like a game engine and a game server, that would be really cool. Especially if we use something highly performant to do it, like C, C++, something like that.
I have a question of like how far do people want to go into it, right? So we could talk about these things on a high level, right? Have conversations about how to build game engines. We have conversations on how to build AWS. Then we can map out like a roadmap for it, and then there's like actually implementing it, and then there's spending like 6 months or so building out some system on that. And it really is like how much do people want to do sort of thing.
I'm much more interested the deeper we go into one thing instead of the high level. Maybe everyone should yell out what their interest are.
I want to beat Unreal Engine 5. We should go until we do that.
I mean, like, I don't want to like bias the group, but I don't mind if we spend all the time on game engines for like until I get bored. And
okay, Edwin, you're too into game engines right now. Well,
yeah.
So the high level decision of you want to go very deep into implementing one idea, regardless of what the idea is, versus a high level on different.
Yeah. No, so as everybody knows, I do switch fads like every other quarter, every other 3 months. But right now it's Unreal, it's game engine, so I don't mind going very deep into it. But obviously, I'm just that's my preference, so I don't want to unduly bias anybody else. But I do believe game engines are very interdisciplinary in terms of art, graphics, AI, math, networking. But enough of my propaganda.
And what kind of game do you want to develop?
Well, right now, like Lee and I are thinking of like RPG,
like multiplayer with a programmatic interface. So that's one thing that I've been working on. So
I can describe that in more detail if you want to understand. I had a pretty clear idea of what I wanted to build. I just am not working with Edwin on it right now because I have my new startup that I just joined.
Well, pitch us on your idea, Lee.
What? Okay, I'll pitch you guys on my idea. Okay, so you guys all know what MMOs are?
Yep.
Okay, so MMOs. There's a community within MMOs. They're like the boxing community. And so this means you run a external software that open source community hacked together. That software deploys a bunch of instances of the actual game and tries to run hacky code that sends injection calls into the individual game instances. So your open source system is sort of controlling all these individual game clients. And these things are problematic because the games weren't designed with this in mind. So they write these shitty scripting languages on top of the games to allow players to control a bunch of these characters. But it's all very separate from the game engine itself, and it has bugs, it crashes, it's not the best experience. And people are paying a lot of money for this, both for pre-built little robots that they can run around with. They pay subscription fees to run around their pre-built robots. They pay, or some people will pay for live subscription fees for each of their 6 or 12 or 24 or however many accounts, and they're paying monthly fees for each of them. It's $100 a month that these people are paying for their groups of robots. So I think there's a market for it, but all of the MMOs are these really big games, and so far all of the MMOs try to keep the MMO players, and the way that they do that is they all try to block these boxers from being able to script in their game as best as possible. So I wanted to build a game where we build an MMO, but not only can you play it like an MMO, but the scripting interface is built into the game. So I can send programmatic commands to control my character and to interface with other characters that I'm running, and I can launch multiple characters at a time if I want. So within the same game client, similar to offline multiplayer RPGs, you have Divinity or anything other than Diablo style games, where you're controlling a bunch of characters at the same time. The offline ones, you can control a bunch of characters at the same time just because they're turn based, or you can pause and then send commands to each of your different characters. But there's this gap where there's no online real time games where a user can control multiple characters, and that's because you would need programmatic control to be able to control multiple characters real time. And so, the dream was to build a MMORPG with boxing as a built-in first-class playstyle. So you can either play a character manually or you can write code to control. This was my plan. This was my dream.
I wonder if you'd have more success just picking a game and then just adding that layer. But I guess that's already what you're kind of doing.
That's what they're doing, but there's no API, right? You have to sort of they had the most success with EverQuest, and they can figure out what memory addresses sort of represent what pieces of information, but then they can control the characters that way as well, but then it crashes sometimes, and there's the community has to put in a lot of work to maintain the scripting engine, because every time EverQuest launches a patch, all the memory addresses change because they recompile the client, and so you have to back out and find out where all the memory addresses have shifted to, so you can recompile your game,
Yeah,
You're
there's a huge component of reverse engineering there. You need to basically hook into the game process, read all the memory, figure out what all the offsets are to the different memory locations, and basically update that every time the game updates.
That exists mainly for EverQuest, some other games as well, but it crashes. It doesn't work perfectly because it's not built into the game, right? If this were like part of the hard part is we're running like multiple instances of the game, and they're having to communicate over like, we can like host our own server, or we can like send these peer-to-peer messages, but there's not like a within the game message bus where we could just send these communications between entities, right? The game isn't built with this in mind at all.
Yeah, I think it's very doable because in the game executable, it would read like text files or whatever from a certain folder from a certain folder structure that it designates, and then players can write these scripts, and then the game would read them alongside and be able to send those messages to the server client to transmit to all the other player clients. So that everybody who's playing the game would see your 5 bots running around. So it's I think it's doable. But like what I'll demonstrate next week is like the basic single player RPG built using Unreal, and then the challenge is to make the programmatic interface and build up the multiplayer.
Yeah. We have to, like, how does the game read, like, instead of just a line of code that tells it to do something, like, how does it read like a code block, right? So there are engineering problems involved in, like, how can you support, like, reading a function, or, like, reading a for loop or a while loop, or, like, setting variables.
At runtime.
Yeah.
At runtime. I think that's the key point, because there's so many game scripting languages that do have the control flow and I believe are Turing complete, but it's the problem, like it's doing it at runtime. It's like interpreting the scripts not during compile time but at runtime. I think it's doable, but I haven't seen a game that really does it yet.
Is there an open source game that we can kind of just take over?
Well, no. Let's just build it from scratch. I already have the single player RPG, like the rudiments of the gameplay, but obviously it's not really programmed to like best practices, or there's like not much programming.
Matt, EverQuest is open source, or there was a group that just cloned EverQuest that just rebuilt it from scratch in open source. And that's the game that is closest to having an open source game that we could start with, but it's just designed so shittily because they're copying this game that just had a really poor design, and they're copying it exactly. I was initially trying to do that, and then the whole point of me like talking to Edwin about this is I had to eventually give up because they seem like they're the closest to it, and it's just not reusable as an engineering system. I think it would be a lot easier to just start from scratch. They have lots of like crashes. They have lots of issues where stuff that you would want to happen on the server side actually runs on the client side, and the game itself doesn't actually support the like programming language. So they're set up where like it's set up like from first engineering design, where like the game is its own executable, and the boxing system
like straps on the outside and launches a bunch of instances of the game and controls each individual instance. And we would want to build this where there's just one instance of the game, and that instance has, you know, the multiple characters that you might have chosen to launch, and everything is built into like one executable, like a real game. So there's just like the basic large architectural structures of a software system we need to change, and so we can't reuse that, or any game.
Yeah, I mean, so I definitely want to encourage this, and like having a project that could be very cool. I was looking towards the high level stuff, but I do kind of want to make this to be like a community that's kind of, you know, if people want it, that's what we do, sort of thing. So we talked through a lot of things in like the past 20 minutes of what we could do. Like we had the AWS conversation about having a conversation around that, and then we also had the video games conversation. I guess the big question is, what do we want to do next week?
How do you force people to give their opinion on what they would actually be involved in? I would be involved in anything if we were coding. Like, I would also be involved in Peloton. Like, I'm down for whatever.
What is this Peloton thing?
So someone, another member, was asking for help to kind of, or just wanted to talk about data engineering processes. And we talked about kind of helping them out with some things. So the basic idea is the thing we were talking about AWS, right? Like, if someone has a problem that's either work related or not work related, and we as a group kind of help them brainstorm ideas or solutions to their problems, so to speak.
Yeah, any idea is great. So as long as it's interesting and yeah, just as long as it's a big.
So I think if you pick a problem and stick with it, you're going to have a bunch of tangential people that are somewhat really interested in it, and then like 2, 3, 4 core people that are really interested in it and that are really driving out the behavior. So for me, it's like, you know, if you're going to be one of those core people, you're more than welcome to kind of drive that decision. But knowing myself and knowing like the work that I'm doing both for my job and my own personal projects, like I'm going to be one of those tangential people, so I don't feel comfortable kind of driving out what the group does.
Yeah, no, that's totally fair, and I don't think it wouldn't be fair for the entire group just to work on one major project. So I think it's good that we can have separate projects, and so I know what the main project I would want to work on and spend most of my time on, but I would love to be a tangential member of any other projects. So I think it's good to have multiple projects and different core people working on each of the projects.
Yeah, and then maybe this meetup is
like maybe I should ask, if we did the game one, would you be down to project manage that? And so next week we could have a day where you sort of introduce everyone to what does the game engine development look like and what are your plans, and then like people can take on tasks as they're interested in.
Yeah, absolutely. Because next week I was talking to Tom about just demoing Unreal Engine and what I've built so far, and I would love to present on that. And I wouldn't mind like essentially helping prove out the proof of concept. But I don't want that to usurp the entire group's time if other people are not as interested. So, and also I would love to join other projects as more of a tangential member. So yeah, so like we could spend like 1 hour on this game engine idea, and somebody else can spend another hour leading another idea.
Okay, let me make a request. Andre, Mustafa, Ryan, Summon, and Tom, like 1 to 5, how interested in this would you be? Interested in like contributing to Edwin's project that he leads?
I mean, I was interested in working on something like an MMO. I'm not as interested in the multi-boxing aspect of it. That's just my 2 cents.
Oh, no, that's totally fine, Andre. I think like at the beginning we still need to build out the engine, so we definitely definitely would love your help. I think the multi-boxing programmatic interface is for later, because we still need to build out the game for still need to build the game first. Yeah.
Yeah, perfectly understood.
And then I think the idea is we're going to try to be good software engineers and figure out like what's the most scalable way to design a game, right?
I'm way too beginner. I think it'd be counterproductive to kind of include myself. I'm happy to observe, but I just don't think it'd be wise for me to really work on anything. Sorry, that sounds terrible, but I'm here just to learn primarily.
Hello? Can you guys hear me?
We can hear you.
Okay, good. I've been trying to speak for the past while, but anyway, I wanted to ask for a request also. Can you like split the tasks into kind of like the proficiency level? Like, okay, this could be done. Just guys follow these articles or whatever manuals. So this is like a beginner level. This is kind of an intermediate level, and this is the expert level. Where each one will take like a specific level within different projects, depending on their experience with the matter, with the material itself.
Edwin?
Dent?
So Edwin didn't answer this immediately, but I'm sure it would be very easy for him, or honestly you, after he shows you this thing. Like there shouldn't be a problem with divvying up like subtasks based on experience level. It should be pretty easy.
Yeah, agreed. Yeah, it's based on interest and also what you think you can contribute to, and what areas you want to learn more about. So there's always work to go around. So I wouldn't worry about that.
You shouldn't feel really intimidated though. Also, there's going to be a lot of like very complex engineering stuff involved, and there's also going to be a lot of like much less complex stuff.
Amazing. Thank you guys. Thank you so much.
Yeah, Matt and Tom, I know you guys aren't as interested in the video games, so like I definitely wouldn't want to usurp all the time, because we can work on other projects in addition to this one. But yeah, but what do you guys think?
I don't mind. I mean, I'm all for the majority. I think learning is learning, and it's good to have that type of knowledge as well. So I don't really care.
And Sunmin, I know want to specialize in data.
Yeah, thank you, Lee. Like, it's very exciting to know that. But I think for me, from my perspective, like I would appreciate who is it, Matt and then Tom, like who is leading the discussion to, like formalize the purpose of this meeting more. Because I'm really enjoying the meeting, learning a lot. Because as you know, like I my lack of like engineering skills. I have a strong quant skills, but I don't have much engineering skills. So a lot of discussions going on in here is really interesting, and definitely a big learning curve. But at the same time, like sometimes I feel like that's okay. What is this made up for? So is this made up for like general software engineering, or is it like targeted for like data use? Sometimes you're talking about data engineering things. Sometimes you're talking about like machine learning things. Sometimes you're talking about like software engineering things. Like I know that CS area is really huge, and that there are a lot of topics that we can touch up on. But I think it will be nice if it can like scale a little down so that the participants in here can benefit more as well, like like save our time. But definitely gaming is a definitely good learning, but I might not be a good like a a lot of like a good resource to be helpful.
Matt?
So I think that's great feedback. I think it's an ongoing question of trying to figure exactly what the space is about. From like a high level, I think is generally like getting a bunch of smart people in a room, and hopefully, in and of itself is enough. I think what we've had a lot of success in is getting people to take a topic and kind of present on that. And I think we've had a few good lectures. They go across the board, right? So we have things that are more generally they've sort of been mid to senior level type things that we've touched on. I mean, I brought up a few times that I'm working on a course that targets the junior spectrum, and hopefully it's going to be finished sometime in about a month or so at this point. I know I keep saying that. But in terms of like what actually the space is about, I think it really is just creating a space for people to learn at its highest level. One of the biggest challenges there is that we generally need someone leading a conversation in order for that to happen. And so the people that have been leading conversations have generally been presenting on more advanced things because that's the things that they're most interested in. And so I all of this is sort of to say I understand I hope to show that I understand the feedback and that we're trying to figure out how best to kind of address it. But a lot of it is dynamic and changing, and we're still kind of hoping to figure out what the particular niche is at the end of the day. I hope that answers your question.
Yeah, no, I love the group, and I love like the interdisciplinary nature, and I learn something new every single time I'm here. So no, I think what you guys are doing are doing a great job.
I think the other thing that could really help is just volume of people. Because simply, like, even early on, I was doing a lot of the lectures, and it was just taking up a lot of time. And so then I tried outsourcing the lectures, and even now, quite a few of you have done 2 or 3 lectures yourselves. And it's like, how many lectures can I ask people to do before they sort of feel like they're putting in more work than they're getting out of it? And so the kind of big next question that can be is how do we drive out a bigger community here and get more people presenting more things?
Yeah, definitely. Because it seems like because it's always the same people, and I love all of you. But it doesn't. I don't think it's even at this size. I think it's great in terms of like getting feedback and getting viewpoints. And I think we're still trying to figure out what the group should be working on in terms of the patterns that we should be following week to week. But I think starting like these big ambitious projects that like Lee always keeps pushing for, I think it's a great idea. And I think people will get interested if we're building out like really fun, big, complex projects.
Wait, so I wanted to ask Matt. So you talk. So I like the idea. Edwin quotes me for the idea or for the push on having like one big complex project that we work on, and I still love that idea. I think if next week we just all said we're going to like pick any of the ideas we talked about, and we're just going to try to build that as a group or start building it. I like that. The other thing is, instead of having people lecture, like what if we just picked something and we all like collaboratively argued about like someone doesn't need to prepare a lecture in advance, right? We can just pick a hard problem and everyone try to like solve it and discuss like discuss how to do something hard, it might be easier and more interactive than someone like one person preparing something. It's easier to prepare because you just have to think of a hard problem, and then the day of, like, everyone gets to work on it. So it might be a good
Actual
thing.
code or like a conceptual problem?
What did you say?
Is this like pick a leak code problem and work on it, or is it pick build AWS and we talk about it?
I mean, it could be much smaller than AWS, right? Like, build a general purpose Python profiler, where it'll like profile like code and what do you call it? Like memory that's used by different subsystems within like a script or a class. Or it could be like, I don't know, like build like a, I can't think of anything else right now.
Like a mini hackathon, right?
Yeah.
Were you thinking, Lee?
Yeah, just something where we can all like work on related tasks and discuss what we're like, like how we built something and ask each other for feedback. Like, oh, my version of it's structured like this, but I'm having trouble with this part. So it could be like a communal like discussion where we're all building our own versions and like helping each other. I think that could be fun.
Yeah, I mean, I think my curiosity would be, what window of time is that? Like 2 hours is not a lot of time to get like a big project off the ground.
Yeah, like a small project. We don't want to extend this to longer than 2 hours.
So I would think like take one of the hard leak code problems and do that is really what I would pick.
Those are kind of scary for lots of people because a lot of them require like very specific knowledge. It's not like, some open-ended thing where anyone can build like a, can like build a simple profiler and then you just want to support more stuff. Like maybe like a medium leak code problem and then you want to like expand upon it. But I think hard leak code problems for this group would be kind of scary and out of the question.
Or like we could have each person like doing a leak code problem according to their interest and their skill level. And then if anybody needs help or wants to discuss, just to like ask the group or ask somebody else in the middle of it. So it wouldn't be one monolithic problem. It would be people would be solving it would be spread out in terms of the problems.
I mean, I like that a lot. Like pick 3 problems, one at each level, and then create like 3 different chat rooms where one chat room is dedicated for the easy one, one's dedicated for the medium one, and one's dedicated for the hard one. Actually, I don't even know if you need the 3 chat rooms. There's like 12 people coming, so. But.
Yeah. I mean, I love leak code, but now it's all about game engines. That's why I'm not going to say anything more.
Oh, Edwin.
I would like to suggest like the learning pattern that we did in the boot camp. I really enjoyed our boot camp, the data analytics engineering boot camp that I did with Edwin and Lee, because it's all about the hands-on practice. It really helped me a lot, like learning fast and then doing myself and then like making a mistake and then learning from mistakes, like something like that. And then of course like instructors share the solution at the same time. So I know it will take a lot of time to create a content, but if a presenter can weekly or bi-weekly or even monthly, like if we can make a little like a hands-on practice, like a content, and then like every month we have a topic, like this month will be a game, or next month will be machine learning, or next month will be AI or something like that. If we can create those kind of small contents that we can work together, I think that will be more effective rather than like listening.
Okay. I mean, I think the big thing that's really come up is people wanting hands-on keyboard experience and actually coding here. So that's definitely something to take in.
Yeah, I need to
Yeah.
put my hands on the keyboard more too. I have a job now.
For a year, 2 years, or 6 months.
I've been here for a week and a half now, and I'm still happy.
Okay.
Very happy with it for now.
Okay. Yeah. I'm kind of happy. Yeah.
Feel it? I think everyone should be, in my mind, in favor of Simon's idea. So we need like a little example, and then it'll be like, let's all build this thing. And there should be like some starter code or some explanation, and then everyone can go work on their own. And someone should, we should be comfortable that we'll be able to solve the thing. Simon, do you think there needs to be like a solutions file or folder as well, or just the starter code?
No, we don't need a solution file, but at least like as you said, someone needs to know the answer at least.
Yeah, you need to make sure that it's solvable.
Yeah, exactly.
Matt, how's your curriculum writing going along? Would you have something to present?
I haven't worked on any like practice material. Is what I'm sort of realizing out of this conversation. And without practice material, it's sort of like it is just a lecture at that point.
I want to see how I can build example, like basic example setup of my time profiler idea, and then you guys can work on like how do you build that like nice little software system. It wouldn't be data science related because Simon, I think only like maybe you're the only other person in this chat room that's data science related. But it would be like how do you do software engineering and testing?
I think so, yeah.
I can do that if other people would be interested, but that would take away from Edwin's video game thing. So maybe we should like start out with Edwin's video game thing, and then once people get bored, we can do that.
Probably the Edwin's video game, and then include some AI features over there that I can enjoy as well.
The AI features are coming. They're just like a lot of engineering in the future. We're just not there yet. The whole point of me being interested in video games is as a reinforcement learning environment.
Oh, yeah, me too.
But
yeah, I'm interested in reinforcement learning as well.
I tried so hard to build a reinforcement learning environment within EverQuest. You haven't been here, but all I've been doing is coding video game EverQuest. That's all I spent time on the last like 4 months. It's just not going to work as an RL environment.
Yeah.
Lee, do you mind checking out this website, generals.io? It's an online game, and I was wondering if that might be an interesting RL environment. It's basically like, I don't know if anyone knows the 4X games.
This could probably be an RL environment, but this is not like real time. This is like you have clear knowledge of what you have knowledge of, right? This is like turn-based graph, like discrete graph, like few number of the search space for this as an RL environment would be kind of similar to something like Snake.
Lee wants to go big, 3D, real world, complex environments, basically.
Matt, do you does that make sense? Do you agree that?
Sandy, I think you're pointing out that like even like Alpha or Go as like a RL problem is you understand the entire space, whereas if you take an MMO, you literally don't know what to do with your character. Like your character doesn't know what a quest is until you
it doesn't know like I should attack that thing, or like like there's sort of this real-time decision-making process of like, should I heal my ally now or should I heal this other ally? Like I'm a group, like what do I think they're going to do? I have to, my decision is sort of reliant on them. Like, maybe there's like 3 things I'm fighting and I have 5 allies. Maybe I have 10 allies and there's 20 things I'm fighting, and all of them have these different properties, and it's all like programmatically defined. But from a machine learning perspective, it's like, how do you condition on these dynamic number of things that all have like, you know, lots of different but like programmatically defined properties. The whole point is there's no RL environments that exist that would require this level of like coordination or this idea of like conditioning on like, you know, conditioning means like what are your input features essentially on like a dynamic number of like entities that you care about in the world, right? So maybe there's like 2 things around you that you care about in the world, or maybe there's like 20 and they all have their different properties. And so this doesn't exist exactly in the RL environment, but if it did exist, it would be very widely used in the like academic machine learning, reinforcement learning space.
I mean, this is similar to what they did with the DeepMind group did with StarCraft, but they had a lot of help from the game developers to actually create an API that would allow them to do reinforcement learning on StarCraft.
Yeah, the problems you're trying to solve are very different than StarCraft, but the engineering project is somewhat similar.
Yeah. Anyway, guys, I have to drop now, but I have very much enjoyed today's discussion. So, thank you.
Thank you, Andre.
Thank you, Andre.
Bye, Andre.
Okay, so video games next week.
Are you comfortable leading that, Edwin?
Well, not for like 2 or 3 hours. But I don't want to take up like everybody's time. So it's like how much time do we want to allocate? Is just me demoing for like 30 to 45 minutes, or is there anything
I
more?
guess the question is, what would it be? If it's demoing like Unreal Engine, like that's like basically a presentation. But if we're trying to like brainstorm how to come up with a project roadmap, like, you know, we could do half an hour of a demo, and then after that we could literally spend an hour and a half talking about what does this look like.
Yeah,
I like that.
Would Edwin Lee, would you two feel comfortable kind of spearheading that and taking on next week the full 2 hours?
What? Edwin, you mean? What do you mean, Edwin?
Yeah, because it does require a lot of background knowledge in terms of game engines. So it would have to be like a continual process. So maybe not like the full 2 hours right now, but just give a demo and have people study up. And then maybe the week following, it could be more of a discussion.
Okay, Edwin can give like a half-hour demo and then a half-hour discussion next week.
Yeah, because the thing is, because there are known unknowns and there are unknown unknowns in terms of like exactly how it should go, and so it will take. This will have to be like it's a project. It's not just I wouldn't want to take up the entire group's time because we don't know what we're talking about.
Okay, we'll fill in the other hour somehow. Maybe I'll do a dynamic programming problem that seems to be a hot topic for some people.
Yeah, actually, Evan wants dynamic programming.
Yes, I see it.
Yeah.
And I don't have to do it next week, but if you guys want to do the whole, you know, it'll take very little setup because I'll just pose the problem and then people can work on that, like, timer idea. I'm happy to do that whenever. But I'm not building the solution for it in advance.
You gotta focus on your job, Lee.
I did that for my job, like, yesterday or something.
Oh.
Just show us your company's code base. That'll be enough.
No, that's not gonna do that. I had to spend so much time because, like, you know, I had to rewrite my system as a context manager. I've never built a context manager before. Like, what the heck is that?
Manager.
What?
What is a context manager?
It's the thing where you say, like, with blah blah blah. Like, you know how you say, like, with open file as file.
Yeah, where it's like
So
fungible.
if you wrap a function with the decorator context manager, it gives it that functionality. And then you need like yields and finally and other stuff like that. I had to, yeah, I had to like programmatically decorate like classes so that they would automatically decorate the appropriate functions within the classes with my like,
Nice.
such a mess. But anyway, yeah, I don't want to build the solution because it would just end up being my work code.
Okay. Yeah, I mean, I feel like with that, sending out the blurb with the email, with the Monday's email, so that people have at least a day or two to kind of think about it before they start programming, it might be nice. And maybe someone does actually program it beforehand, so that we actually have a solution by the end of it.
I mean, Lee already has his work solution, so he knows what to do.
As has been said, he's not going to present his work solution.
No, but he knows he can talk through the general solution.
Yeah, but I'm not going to tell people like my solution, right? Like it's like, how do you test this thing? Like, how do you build the thing? Like, what are the user like? How do you? Anyway, there's a lot of different stuff. It'll be much less of a fun experience if I tell people how to do it.
Yeah, yeah. But in case we get stuck, we can always ask Lee. So.
Yeah. I built something that, passes the highest level of software engineering scrutiny you can imagine. So, it's at least reasonable. And I'm sure it could be built in like an hour or two. The reason why mine took so long is because our like lint checker takes forever, and so every time I like wrote some code, I had to then like lint check it, and I always write like poorly linted code.
Are you pushing in order to test?
No, I have an offline linter, but we just have, like, honestly, like, our existing system already breaks our linter. It's a very early beta product. It's a very early stage startup. Let's not talk about that.
You can't fix that linter, man. I don't know what to tell you.
Yeah, I don't know linter's taking that long. Yeah, unless it's a very custom linter that will like cure cancer and send a man to the moon. This seems like a very powerful linter.
I don't want that.
Linters should speed up development productivity, not slow it down. It's really what it is at the end of the day.
It sounds like
let's not make fun of Lee learning to be a baby software engineer.
Sorry.
I'm growing up. I got my training wheels on, okay?
You've been doing this for the past 10 years.
I've always been the most senior software engineer doing whatever the fuck I wanted, though. I've never been in like a team of real software engineers.
I mean, I feel like they're few and far in between.
Yeah, I agree. I think I've had like one passion project where my partner had like real software engineering expectations on me, and so I've had this experience once before, and that was really hard. I actually broke him because his expectations were so hard that we weren't able to like build the machine learning stuff that we wanted to build. So I actually broke him away from strict software engineering. And this time I'm not going to be able to break away from it.
All right, that was fun, guys.
Yeah.
Yep.
Yeah, it seems like a great time to stop it. Thank you, everyone.
Thank you, guys.
Goodbye.